All right, so let's talk about persistence. So what we want to be able to do is store all the data that we've been collecting from the user, in this case the faculty. We want to be able to permanently store that in long-term storage. And what we're going to look at is how to do it in a relational database. So we already have a data model. We already have a data model that we worked on last week. We created a user, we created courses, we created quite a few things last week in our models, right? Where we created users. Users had many courses that they had authored. Each course had many modules. Each module had many lessons. Each lessons many topics, and each topic many widgets, right? So lots of one-to-many relationship between these. And what we'd like to be able to do is store this information in a relational database. And there's many different options, and oftentimes there's not one way of doing it. The most common way of implementing all these one-to-many relationships of a user to courses to modules to whatnot, all those, is to have a when you map it to a relational database, is to have each parent and child, each one in a one-to-many relationship, to have foreign keys relating to each other, right? So, for instance, for every user related to for multiple courses, each one of those courses have pointers back to the user, telling who was the author. Same thing with courses to modules. The modules would have references back to the course they belong to. But notice that the way you implement this in a relational database is a little bit backwards on how we have been modeling this in Java, right? In Java we have if you have a user and which has many courses, which has many modules, so there's one-to-many. Typically, notice that the way we implemented this was that the user has a list of courses, a course has a list of modules, a module has a list of lessons, and so on and so forth. Right? That's the natural way of encoding this. Right? So it starts here. The pyramid of this data structure starts at the user, and the user has a reference to courses. Notice that the course is ambivalent about the user. It doesn't know. The course doesn't know who its author is. Right? It is the author, the user, the faculty, who has references to the course. You see that? But when you're going to implement this in a relational database, right, instead of the user having references to multiple courses, right, that's the Java way. When you're going to implement this in a relational database, actually it's backwards, right? You implement it by having a foreign key at the course side, pointing to the user who authored it, right? Who they're related to. So if you have multiple courses, each one of those courses would point to the same record, saying, "Hey, that's my author over there." It's kind of backwards. Right? So that's one of the challenges mapping a object-oriented data model to a relational data model. Right? That's one of them. That's backwards, right? Another one of the challenges is when you consider inheritance, right? Where you might have a faculty and a student that are both inheriting from a base user, right? Or down in widgets here, if you have widgets, you have multiple types of widgets, right? You have a YouTube widget, you have a list widget, a paragraph widget, any number of widgets. So this is a very, very natural thing to do in Java, in object-oriented programming. But it's not at all natural in a relational database, right? databases just don't support this, don't support inheritance. Nevertheless, we have to find a way to map these two worlds. Right? We have to map the object-oriented world that supports these features to some storage that supports something equivalent, so that we can store this in records that are related to each one of these, and then be able to reconstruct this on the way out, right? Be able to go back and forth. So to simplify our world, we're not gonna get into too much databases. We only have one lecture, maybe the next one too. We're going to use a library that does this for us automatically, right? That does the mapping between these two worlds for us without thinking too much. Okay, and the library is the Jpa library. Jpa stands for Java Persistence API. Right, it's an API for persisting Java objects. We need to configure our project to talk to a database, first of all. We need to configure a couple of things. And then we need to start annotating. We need to start telling the library what do we want to store in the database. What is it that we want to store? And to that end, we're going to be using several annotations, several JPA-specific annotations. Say, hey, you see this class over here? It's not just any class. It actually references something in the database. Okay. All right. So let's get started. Let's first of all let's configure our project to talk to a database. Let's do that first. Let's see if we have a database first of all. Let's see. I believe I might have been playing around here with some of these. I might already have some information here, so let me throw away any data that I might already have here for Whiteboard Fall 2018. Let me drop any widgets that I might already have here. So drop table. And let's drop that. So we are with a pristine database. Let's refresh that. Okay, there's nothing in there, right? So there's a whiteboard-fall-2018. So let's connect to that database. So presumably we already created that schema prior. This is MySQL running locally on my machine, and so let's connect to that. So to configure that, we do that. We configure it in our project. Here's our project, the one started working last week. In the resources directory, you should find application.properties, okay, which is currently should be empty. Okay? So application properties where you can configure JPA to connect to a particular database and certain other features that you can turn on and off. So I'm just going to copy from here what the configuration is. I'll just copy this. I'll paste it in here. There we go. So the first configuration here tells me what database am I connecting to. And so it'll be localhost, so it's running locally, localhost. The default port is 3306, and the database names, I believe, is whiteboard_fall_2018. Okay? The username and password, I think I've created a username called webdev with the same password. Here we're configuring, telling the database that, you handle the database creation. Create. You handle it. There's all these Java classes, right, that have their names, have fields, have properties, right, those Java classes. Do a best guess at what the structure should be in the relational database. Right? So, for instance, a good guess might be that for every class there might be a table. Right? So, if there's a user class, there should be a user table. If there's a course class, there should be a course table, right? And so on and so forth. Okay. So here we're configuring, telling JP to handle that. Look at the Java classes, create the structures for it. Also, we can configure it to be verbose about it. As it creates these structures for us, jot down or put it in the console. Tell us what are the commands that you're using to interact with the database. Show the SQL. A couple other things that can be configured here. Let's turn these on. Another thing that we can configure is what are the names of the tables that you're going to choose? What are the names of the fields that you're going to choose? Because Java and SQL have different naming conventions, right? In Java, typically you do camel casing, right? It's case sensitive, whereas SQL typically is not case sensitive. So typically what we want to do is replace all the capitalization in Java by underscores, right? So we can configure that as well. We can also configure what what engine. How do we want to encode the database structure? What kind of names do we want for the foreign keys, for the primary keys? So to do that, we can configure what engine do we want the database to use. INO is one of the more common ones, so I'm turning that on. But you can configure any number of dialects depending on the vendor. The different vendors, different versions of those databases will have different dialects, right? So you can configure exactly what you want. Ideally, what this allows you to do is to have your code independent of the vendor, right? So that there's only one place that you can configure this, so that you don't have to modify your source code ever. More about being more verbose. We want to see the SQL query, even with the values that it's using to send, or that's sending over to the server. We want to format it using tab and new line so that we can read it. Otherwise, it would be just a single line. It'll be really hard to read. And just trace everything you're doing. Right? Every decision that the JPA is going to do for us is going to trace it into the console log so we can look at it. Now, typically, we want to turn all these off in production. Right? This is very useful for development. Right? So we can see exactly what the database is trying to do, talking to the database. But in production, we would turn this off. We would typically also turn this off as well. And here, this DDL, auto, typically for us getting started with a brand new project, there's no database yet, create is perfectly fine. But if this were a database that already exists, okay, typically you would turn this off. You say, no, don't create anything, because the database already exists. It's been around for quite a while. I don't want you mocking with it. Don't erase my tables. If you say create, it's going to drop your tables every time you run your project, which is annoying and you forget about it. Especially if you have data already stored in there and test data and whatnot, it's really annoying. As your database structure matures and you're more confident that that's exactly the structure you want, you might want to change this to update so that it will only do minor updates. Right? It won't drop the table. If it needs to add a column or change something or some data type, update will do that for you. It'll change. If it sees any changes in the Java, it'll do the changes accordingly in the relational database. Eventually, once you're happy with the structure and you don't want to change it ever again because if it's mature, you would turn this off. Right? It says do not change the SQL, especially if it's a SQL that's been around for a while. We're going to start with create since we don't have a database whatsoever. All right, let's get started. What else? Other configuration that we'll need to do is actually download the library itself. The library is not default. Is not loaded. Not available by default in your project. So let's add that to your project descriptor here. We'll do the open the POM and declare here that we want, in the dependencies, we'll add that additional dependency. Okay, so we want to download JPA, right? And we also want to connect to MySQL, right? And you would use the correct version of MySQL that you might have locally installed locally. Once you do that, you probably might want to update the project. And perhaps recompile. Am I in the right place? All right, so npm clean install. I'm sorry, I've been doing Node for npm clean install. All right. What is it complaining about? So, yeah, MySQL. I'm sorry? Oh, it's hyphen? Oh, okay, thank you. Application properties, this is hyphen. Okay, well that's going. Let's get started. Let's play around with some of these, storing some of this information in the server, in the database. Let's see what we have so far. So this is the source code that I shared with you last week, and I think it's running already. On the client side, it's a simple client. You have users. Let's see, we have users, and if you select a particular user, it shows there that user's courses. If you select the course, it selects the modules. Module selects the lessons. If you click on the lesson, it selects the topic. If you select a topic, it selects the widget. Okay, and this is currently hard coded in the web service that I shared with you earlier last week. So let's just go over it real quick on what we have so far. Let's see, we have the models, right, where we have a user containing multiple courses, each course maintaining several modules, each module having many lessons, and so on and so forth, right? So that's we know that, right? What else do we implement here? So web services. The entry point is the user service. This user service, when you what it does is that it has some hard-coded list of users here. For instance, it has these users: Alice, Bob, and Charlie. Courses for those users, then modules for those courses, then lessons for those modules, topics for those lessons, and widgets for those topics. And then here I use a static initializer to initialize all these arrays. Yes. This could have been prettier, right? Could have been some file that read from there, and then you loaded that. And some of you did that, which was pretty cool. But nevertheless, what was really the point of the assignment was to create all these endpoints, right? /API/user, return all the users, or return a particular, or create a new user, or register, or profile, log out, log in, all using the array of users in here, right? Okay. Yours might have been prettier. I don't know. And there's a service for each one of these, right? So there's also course service. So course service allowed you to navigate to the courses for a particular user. Right? So given a user, I could ask for the courses for that user. Right? So again, it first went to the user service to find that particular user, and then from that user just return the courses. Right? To create a course, again, it would find the user. It would find the user by ID in the user service, and then get the list of courses, and then append a brand new course that came from the client. Right? And then it would just return all the courses. Find course by ID, again, it returned the user. It iterated over all the users, and then iterated over the courses until it found the course for that ID. So this was a little brute force. Perhaps a better way might have been that I have the user, and I can skip over all the users until I find the user that I want, right? And then find the course that I want. That would have been perhaps a little more, a little prettier. Nevertheless, just to point out that this is all server side, no database whatsoever. Okay. Same thing for the module service. In the module service, we could, given a particular course, I might ask all the modules for that course. So I exposed in the course service find course by ID, which we just looked at 2 seconds ago. And once I find the course, I just return all the modules for that course. Right? Again, all this is hard coded in the services. Right? None of this is being stored in the database. What else? Lessons. So these all look fairly similar, right? For the lesson, what I did, I changed it a little bit, right? Instead of just passing the parent, and then the ID, right? I made this a little more verbose, so that here you pass everything, the entire context. Right? So I pass you the user ID, the course ID, the module ID, everything. Right? This is a little more stateless. For those that have considered implementing this as a stateless application, where the state is being maintained by the client. The client passes everything the server needs, right? Passes the user ID, the course ID, the module ID. There's not even need for a HTTP session, right? Because I can derive the session, I can derive the state entirely from the URL. And there's no need for me to remember anything, right? Anyway, so I iterated and found the particular lesson and returned that. For topics, I believe I did something similar. It just was an additional loop, inner loop. And for the widgets, I believe was an even additional loop, right? So it's very easy, right? I would find first the user, then I would find the course, then I would find the module, then I would find the lesson, and then the topic, and then I would retrieve all the widgets for that topic, right? And this is exactly what a join would do, right? If this were a relational database, right, and you're trying to join these tables, that's what would happen, right? You would join all these tables, iterating until you match all these foreign keys and primary keys to retrieve that. All right. Excellent. Okay, so let's get started by being able to map some of these objects, some of these widgets, for instance. Since this assignment focuses a lot on the widget side, right, and how to interface that with the Redux part, right? Maybe we should start there. All right, so let's get started backwards. Instead of having the user, the courses, the modules, all the way down to the widgets, let's start with the widgets and then work our way back up to the topics and whatnot. Okay. All right, excellent. Let's play around with this. Let's see. Let's get started with mapping the widget to a table, right? Let's do that first.